The idea with a perfect square is we'll have some binomial that is squared. Squared simply means that it is multiplied by itself. So this is really a plus b times a plus b. If we multiply this out with FOIL, a times a is a squared. A times b is ab. B times a is another ab. And b times b is b squared. Notice the like terms in the middle are exactly identical. Those like terms in the middle come from multiplying the a and the b together, and it's there twice. For this reason, we have a middle term which is twice the product of ab, combining the like terms, plus b squared. This gives rise to our perfect square shortcut. If we have a plus b squared, we can multiply them together by squaring the first term, and then taking the product, ab, twice. ab and ab is 2ab. And finally, we can square the last term to get b squared. This is a shortcut that becomes very valuable as we continue studying algebra. It's one that if we know well, it will give us an advantage as we continue moving forward in this course. Let's try some examples where we can see these worked out. Here is a problem where we have a binomial square. To square it, we can square the first term, x squared, and then we look at the product. X times negative 4 is negative 4x, and another negative 4x will give us negative 8x, because it's there twice. And finally, we square the last. Negative 4 squared is positive 16. And this becomes our product. Let's try another example that might be slightly more involved, where we see the binomial squared. Again, in this problem, we can follow the same pattern. Squaring the first term, 2x squared. 2 squared is 4, x squared. And then we look at the product. 2x times 7 is 14x. And another 14x will be positive 28x. And then we square the last term. Squaring 7 will give us 49. It is important to note that when we square a binomial, we will always have 3 terms in our solution. Quite often, students forget the middle term, which comes from multiplying the terms together twice. If we can remember the shortcut to square the first, multiply them twice, and square the last, we can quickly square our binomials.